Beyond Aero advances hydrogen aviation design milestone. Beyond Aero has completed the preliminary design review (PDR) for its hydrogen electric business aircraft, marking a transition from early-stage concept work into detailed engineering and validation. The milestone indicates that core systems, including hydrogen storage, fuel cell propulsion, thermal management, and safety architecture, have reached a level of maturity consistent with certification planning. The program is being developed with early alignment to CS25 and Part 25 requirements, the same regulatory frameworks applied to commercial transport aircraft. This approach is intended to reduce certification risk later in the development cycle, particularly for propulsion technologies that have historically faced delays due to regulatory uncertainty. Rather than adapting an existing platform, the aircraft is being designed specifically around hydrogen electric propulsion. The configuration features a twin-prop fan layout powered by fuel cells, with gaseous hydrogen stored in 700-bar tanks positioned above the wing. This design choice avoids the added complexity of cryogenic hydrogen while supporting nearer-term operational feasibility. Infrastructure considerations have also shaped the design. Compatibility with both fixed 700-bar systems and 350-bar mobile refueling units is intended to support operations within current and developing airport capabilities. External tank placement enables passive ventilation, addressing safety requirements associated with hydrogen storage. Aerodynamic performance has been validated through wind tunnel testing, with results aligning closely with computational models. With propulsion, storage, and airframe systems now integrated into a certification-oriented architecture, the program enters its next phase with a reduced level of technical uncertainty compared to typical early-stage hydrogen initiatives. Certification strategy and ecosystem development take shape. A central element of Beyond Aero's strategy is its decision to pursue certification under transport category standards rather than alternative or experimental frameworks. This reflects a focus on long-term scalability and operational acceptance, particularly within business aviation markets that demand high safety thresholds. Certification planning has been embedded into the program from an early stage, including the use of certification review items to address areas where existing regulations do not fully cover hydrogen propulsion systems. Engagement with the European Union Aviation Safety Agency (EASA) is already underway through a pre-application agreement, while progress on design organization approval continues, with initial phases completed and subsequent stages in progress. Validation efforts are advancing in parallel with design work. An 85-kilowatt prototype has already undergone flight testing, while higher power propulsion data, approaching 800 kilowatts, has been generated through full-scale testing campaigns. Ground-based capabilities now extend to 1,200 kilowatts, supporting system-level verification as development progresses. The company is also working with a network of aerospace and engineering partners across fuel cells, structures, thermal systems, and certification processes. This collaborative model reflects a broader industry pattern, where newer entrants rely on established expertise to support industrialization and manage development risk. Alongside aircraft development, infrastructure planning is being addressed through agreements with airport operators and hydrogen supply partners. More than 10 memoranda of understanding have been signed with airports, alongside over 16 with hydrogen production and distribution stakeholders. By focusing on gaseous hydrogen and existing refueling approaches, the program aims to align aircraft readiness with the pace of infrastructure deployment. Taken together, the PDR milestone represents a step toward aligning technology development with certification, supply chain, and operational considerations, factors that will ultimately determine the viability of hydrogen electric aviation beyond the prototype stage.